Welcome to this series of short demo videos about blueprint patterns. My name is Ricardo Noriega and I work at the Emerging Technologies Group in the Office of the CTO. In this very first presentation, we will talk about this new concept that the edge computing team has been working on. First of all, we need to highlight the change of mindset that the edge computing realm represents comparing to a multi-cluster architecture. Leveraging a multi-cluster architecture, services tend to be distributed across a small number of clusters, probably deployed in different footprints, public cloud or on-prem, with a certain number of characteristics that make those clusters special to the users, like development, staging, or production clusters, geolocation redundant, etc. However, in the edge computing world, we will see users distributed across a very large number of identical clusters. This is the pets versus cattle paradigm at the cluster level. Having this in mind, reproducibility is one of the most important goals. Rebuilding a cluster must produce the same result every time. There will be conditions for highly secure environments where reaching these edge clusters is not possible, so all sessions must be edge initiated, and operations must be autonomous. Hardware provisioning and maintenance will be performed by low-skilled labor, so the deployment processes must be simple and automated. The blueprint pattern was popularized in the Airship project, driven by AT&T, and it has become standard for edge computing deployments. It is also being used in Acrano, a project from the Linux Foundation Edge. Basically, a blueprint is the definition of the whole stack for an edge computing cluster or site, starting from the infrastructure through the cluster characteristics up to the applications running on top. A blueprint is a cookie cutter for all sites deployed of a specific flavor or purpose. The way we have structured a blueprint allows you to compose from a baseline, adding profile and site-specific variations, and can be co-designed by multiple teams. All aspects of a blueprint should be declarative, so they can be easily version controlled to facilitate auditing, site rollbacks, and management via GitOps. A future goal would be to have a library of blueprints simplifying the deployment of complex edge stacks, such as vRAN or industrial use cases deploying AI/ML algorithms to infer data from sensors. Our blueprint structure covers both day 1 and day 2 stages, and it leverages customized to create configuration overlays. They are based in 3 layers. The base layer that contains common configuration to all deployments, a profile layer that contains configuration for specific profiles or footprints, such as testing or production, bare metal or AWS, and finally, a site layer that contains delta configurations for specific sites. For example, patching the name and domain of the cluster, specific hardware configuration, information, credentials, etc. Each of these layers has the same folder structure, 00 install config and 01 cluster mods to include all day 1 configuration. Basically, high-level install config and deployment manifests. And 02 cluster add-ons and 03 services for day 2 operations, like additional cluster services and workloads. Rendering with customized a blueprint site will take into account these 3 layers and these stages, and as a result, it will create a set of manifests that can be passed to the OpenShift install binary for IPI deployments or a set of ignition files for UPI deployments. And it will create the same kind of cluster in a repeatable manner. We have developed a helper tool called K9CTL to automate this process. I want to emphasize that this is not a wrapper of the OpenShift installer. It's basically a tool that downloads the required binaries, downloads the blueprint, definition, and render the manifest to create a consumable output by the installer. In the next video, I will show you how to deploy a blueprint in a public cloud, and will explain all the manual tasks that K9CTL automates for you. Thank you very much.